We've seen what it looks like in a truth table when we have two statements that are equivalent. We'd also like to see what the truth table looks like when we have statements that are not equivalent. And in order to see that, we're going to start with a pair of statements that aren't equivalent, make a truth table for them, and see what that looks like. So the two statements we're going to work with are these two. It is not the case that P or Q. And the other statement is not P or not Q. Looking at those, you might suspect that they are equivalent, which is why a truth table is helpful in helping us realize that they're not. So to set up our truth table, we'll need to make a plan. And the beginning of our plan is, well, first we'll need columns for our simple statements. We have two simple statements, P and Q. Since we have two simple statements, we're going to need 4 rows in our truth table. And then we'll fill in the values of P and Q. Q, our rightmost statement, its truth values alternate true, false, true, false. And then P will have 2 trues and 2 falses. If we had another statement to the left of that, the pattern would be 4 trues and 4 falses, and so on. Okay, now that we have the columns for our simple statements, next we want the columns that we need to symbolize our first statement here, not P or Q. Now remember, when we have a complicated statement like this with more than one connector, we work kind of from the bottom up, from the inside out. We start with negations of simple statements. We don't have any of those. Then we work with whatever's in parentheses. Here we have P or Q. And then once we have everything that appears in parentheses, we look for negations of what we've already symbolized, and that's the only other statement there. The negation of the statement, P or Q. So we've now finished setting up the columns for our first compound statement. Let's go ahead and calculate those truth values. So P or Q, remember or is true as long as at least one of the statements is true. So true or true, we want true. True or false, still at least one of those is true, so that's true. False or true, at least one of those is true. False or false, okay, those are both false. That's when or is false. To fill in the next column, we're negating P or Q. So we'll look at our P or Q column, and we'll just take the opposite of whatever truth value we see. Opposite of true is false. Opposite of true is false. Opposite of true is false. Opposite of false is true. And that's one of the statements we're actually interested in. I'm going to highlight that so that I can look at it more easily once I get done with this. There's the first column that I'm interested in here. Now I'm going to move on to working with my second compound statement, and I'm just going to keep extending the same truth table because I want to look at these side by side. So again, we start with negations of simple statements. We'll need a not P column and a not Q column. And then we don't have any parentheses. In fact, all that's left is the full statement. Not P or not Q. So now we have our second full statement symbolized. We'll want to compute the truth values for that. So not P we look at the P column and take the opposite of whatever we see there. So the opposite of true is false. The opposite of true is false. The opposite of false is true. The opposite of false is true. Not Q, we do the same thing with the Q column. Not true is false. Not false is true. Not true is false. Not false is true. And then finally, to find not P or not Q, we'll look at the not P column, the not Q column, and remember that OR is true as long as at least one of the two things that we're ORing together is true. So false or false, that's false, right? They're both false, so OR is false. False or true, there's at least one true there, so OR is true. True or false, OR is true. True or true, OR is true. And this is the second column that we're interested in here. We've now made a truth table that shows both of our compound statements. And we highlighted the columns with the statements we're actually interested in to help us see what's going on. And now the question we're asking is very simple. Are those the same? Well, no, they're not the same, right? In the second row, where P is true and Q is false, then we have not P or Q is false, but we have not P or not Q is true. And then in the third row, where P is false and Q is true, we have not P or Q is false, but again, not P or not Q is true. Since the statements have different truth values in those rows, they are not equivalent. So when we want to determine whether two statements are equivalent, these are the steps we use. First, we make a truth table for each statement. Then we check the truth values in all the rows. If the two have the same truth value in each row, they're equivalent. If they're different somewhere, they're not equivalent.